So this week we learned how to use different medias and things in the different medias to help differentiate between different bacterias, and also how to select specific bacterias to either grow or die out based off of our desires, or how you could make an agar both. So I'll start with our EMB, our eosin and methylene blue dye. And as you can see, the only one that has grown is the E. coli, and it has a really dark color. So basically, the eosin and methylene blue dye kills gram-positive bacteria. Therefore, it is a differentiation for gram-negative and gram-positive, because the only ones that will grow are going to be the gram-negative. Now, E. coli is the only gram-negative bacteria that we used in this media, so therefore it makes sense as that's the only one that grows. Now, it is differential between whether the bacteria can ferment lactose or not, because there's lactose in this. And if it can ferment lactose, then it lowers the pH and creates a dark color of growth on it. So as you saw, it had a really dark purple color to it, or actually even darker than purple. But anyways, that proves that our E. coli was able to ferment the lactose. If it's unable to ferment the lactose, it doesn't mean that it won't grow. It just means that it will grow in a different color, not in that darkish color, which is lower in the pH. So that's how it can be a differential media as well as a selective. So ours was selective for gram-negative E. coli, and it differentiated between whether it could or could not consume lactose or ferment lactose. And we saw that it could because it had the dark color change. The next one we'll talk about is our MacConkey agar plate. And we did selective and differentials for that as well. As you can see that we have a bright pink color to our media. And so it is selective against gram-positive because the crystal violet and the bile salts that are in the MacConkey agar prevents the growth. It lyses the cell wall of the gram-positive bacterias. Now, gram-negative don't have that exact same cell wall, therefore they can grow. So that's how it's selective between positive and negative. So as you can see on ours, the one that grew was, again, the E. coli, because gram-negative are the only ones that would grow. And then it differentiated between whether it could or could not consume lactose. And as we already discussed with the EMB, it can consume lactose. And we have proof of that in our MacConkey agar as well, because if it can ferment lactose, then it creates a really pink color to the bacterial growth, which we saw in our plate. I'll show you again. A really pink color. The last one that we have is our mannitol salt, and I'll show you it. It's going to be harder to see. You can see at the top right there how it has that light colored growth. So it can be selective because it has 7.5% of normal saline in it, and only certain microbes are able to grow with that much salt content. So it selects between which microbes can and cannot grow with that level of salt. It can differentiate between because of the mannitol that's in it. So mannitol is the nutrient that's in the mannitol salt agar plate. And if the bacteria can ferment mannitol, then again it lowers the pH, which then reacts with this phenol red. This one has a phenol red added to it, a dye. And that phenol red is a pH indicator that when it lowers because of acid byproducts from the fermentation of the mannitol, it creates a yellow color to the bacteria. So mine was kind of off-white. It was light and white, but it also went from more white to kind of an off-white, yellower white between the 48 and 96 hours. So I'm considering it to be able to consume mannitol. It may not be as yellow as it's supposed to be able to say that, but I feel like it should be able to consume mannitol because it did start becoming more yellow the last 2 days that I had it processing and fermenting. So I'm saying that it does. So basically we learned that you can select which types of bacteria you want to grow either by adding nutrients to it that will enhance growth of that one and make it dominant, or inhibit the growth of some, which makes another one dominant. And we also learn how we can differentiate between those based off of either pH changes when certain nutrients are consumed, or I think that's the only way that we learn to differentiate. Yeah, I think so. So, yeah, we learned that E. coli is gram-negative, that can consume lactose. And we learned that Staphylococcus epidermis in our mannitol salt was the only one that grew. And it's turned kind of yellow. And it was the only one that could grow in the salt.